So now continue with mesomeric effect. So let's draw various structures benzene like phenol, aniline, thiophenol, amine, aldehyde, benzaldehyde, benzoic acid, benzene sulfonic acid, ketone, nitroso group, ester, 1-degree amide. Now let's consider these all groups. Okay, we can also name them. If we name them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's name them. Now if we see further, what we have to categorize them, which is plus M group and which is minus M group. So we have to make a list of plus M group and minus M group. Which of the compound fall, which of the group. Okay, we only talk about this group. Okay, the group attached directly with conjugated benzene ring. Okay, that we call mesomeric effect. P pi bonding we have seen previously. What does mesomeric effect mean? It is a group. When resonance is doing by a group, then it is known as mesomeric effect. Okay, so now if we see, when we see phenol, in phenol the oxygen is donating its lone pair to the system, so that's why it fall in the category of plus M group. If we see second amine, it's donating electron pair, it has a lone pair, it is donating to the group, that's why it fall in plus M category. Third, thiophenol, in thiophenol sulfur is donating electron to the benzene ring, that's why it is plus M group. NHR, okay, amine nitrogen is donating lone pair, so it is plus M group. CHO, aldehyde in aldehyde we see C double bond OH, it just takes the electron from the system, that's why it falls in the category of minus M. If we see an example of benzaldehyde, COOH, when it is directly attached with some system, so actually it will take electron from the system. Okay, so it is categorized in the minus M category, so it is in the category of minus M. SO3H, if we take an example of again, it will take electron from the system, so it is also fall in the category of minus M group. COR, aldehyde again, it will take electron from the system, so it will fall in the category of minus M group. NO group, okay, if we talk about NO group, okay, just hold for NO group. Okay, let's see 10 and 11. So here oxygen is donating its lone pair to the group, that's why it fall in category of plus M group. Here nitrogen is also donating electron to, that's why it is called plus M group. So here it is a categorization of minus M and plus M. Now if we see NO group, if we see NO group, then NO group we name it as a nitroso group. If we talk about nitroso group, so in nitroso group we know that nitrogen has one lone pair because there is only 3 bonds are there, and nitrogen after 3 bond it contains one lone pair in, so it is in p orbit lone pair. Why we call it in p orbit? Because it is not hybridized, because it is taking participation in hydration, so it is also in the category of plus M group, because it is donating, and other and one side the oxygen is taking electron pair from the system, so it also fall into the category of minus M group. Okay, so now if you see again, the nitrogen has a lone pair and it is donating electron to the system, that's why it fall in the category of plus M group. But it's also have double bond O, and that is one more conjugation, so it is taking electron from the system, that's why it is known as minus M. So in case of ninth option, it both have plus M and minus M. So when it is asked what is plus M, which is, so we will dominate minus M, we will consider it as a minus M groups, because after experiment it was seen that it is overall a ring deactivating group. Okay, so ninth is overall a ring deactivator, so it falls under the category of deactivating group, that's why we dominate the minus M group over plus M group. Okay, now if you see further example, compare the charge. If you see example, that we have to compare the charge density on the ring. Now if we have to compare the electron density in the ring, we know all these three are electron, all the three are plus M group. Okay, we know all these three are plus M group, all these three are ring activating group. Okay, ring activating group. Now we have to compare their strength. Okay, electron density in the ring. Okay, we have three ring, 1 2 3. We have to see where electron density is more. Okay, so we have to check the where the plus I order is more. Okay, so we know the more the electronegativity, more electronegativity, more electron holding capacity, more electronegativity, more electron holding capacity. So more electron holding capacity, so less releasing power, it will release less electron. Okay, so more electronegativity means less activating. Okay, so now if you see, CH2 minus is more NH minus than O minus. Okay, it is less electronegative, so more electron donating tendency. Okay, now if we compare, the oxygen is more electronegative, that's why it is behind the nitrogen. Okay, so these are the electronegativity series. The 4 electronegative: fluorine, oxygen, nitrogen is approximately equals to chlorine. Okay, now here we also have to make the list of what are the plus M category and what are the minus M category. Okay, so if we see the plus M category, the plus M order we have to fix, one order we have to fix. Okay, rest we can compare by them. So by fixing one order, we have to see CH2 minus is greater than NH minus is greater than NH2 free radical, NH2 group, amine group, then OH, then OR. Okay, so these are OH and OR. So this is the order of plus M group. Okay, now in plus M group, CH2 minus is greater than NH, then NH2, because a negative charge has more negative charge has more electron density, so it will be negative charge will be greater than a neutral. Okay, in case of plus M order, so it is neutral. Okay, then OH, then OR. Okay, so due to polarization here, if we compare the between OH and OR, suppose it has minus delta 1 charge and it has minus delta 2 charge. Okay, so now if you see, the magnitude of minus delta 1 is greater than minus delta 2. Okay, because here the polarization, due to polarization, Due to polarization, here we know here it is more polarization because it is also in the form of acid. It is form of acid, so here it is more polarization. Here it is less polarization. More polarization between these means this has more electron density here, so it will shift, it will repel more. Okay, here it is more electron density, so more repelling power, not more repelling power, more donating tendency. More donating tendency, so that's why it